Hello everyone, welcome back to another video. And actually, this video is for the CHC undergraduate students, and I've already discussed about bubble short algorithm in my previous video. So if you don't watching, then you can just watch that video. And today's video, I am actually going to share about selection short algorithm. It's actually pretty simple and very basic. So, what is actually the selection short? So, selection based, it actually like the name actually tells everything. The name selection, so it means it's actually a selection based sorting algorithm. It's actually selection-based sorting algorithm, and the second thing is it needs to find the minimum element, and it needs to swap it to the correct position. I mean, I need to find the minimum element, then I need to swap it to and I need to actually place it to the correct positions, and then the same things will be repeats for remaining elements, and it actually simple but actually it inefficient for large set of data. Well, now it is the most important thing, how it works, that we need to understand. Well, we need to find the minimum element in unsorted part, and we need to swap it with the first unsorted element, and move boundary of sorted part by one, and repeat until it is sorted. And after each pass, one more element is in its final position. So I think still probably many of the things are just go above your head. So let's visualize this, like how it actually works. So let's consider these elements. So this is an unsorted elements: 64, 25, 12, 22, and 11. So what is our main theory for selection algorithm? Selection sort, we need to find the minimum, right? And we need to place that element to the correct position. So on the first iteration, we need to find the minimum. Like actually, every iteration we need to find the minimum and place it to the correct position. So here you see this is like the 64 is the first position, and we need to scan for the minimum. And we found the minimum element is 11. So what we need to do, the for the first pass, actually we need to place the minimum to the first place, because that is actually his correct position. So we need to scan the minimum and place it to the correct place. And so how we can place it to the correct place, we need to swap. So we need to swap 64 to 11 and 11 to 64. Well, so now 11 is now in place. So which is so the first iteration done, and on the second iteration, the same approach will be happen. Like we need to find, and again we need to find the like the from the minimum from the remaining elements. I mean, 12, 25, 22, 64, and we place it to the correct place. And on past iteration 3, we need to place then from the next remaining elements: 25, 22, 64. 22 is the minimum element, and we need to swap 22 with 25. And here you can see 22 placed on the 25 positions, and 25 is on the 22 position. So and finally all sorted, and you can see it's 11, 12, 22, 25, 20, 64. Well, so here is an example of an Python implementation, like how it works. So we need to calculate the length of the array, and then this is actually the iteration. I mean, how many iteration we actually need to run to make the elements sorted. So then we try with minimum index 1, and that is I, and then we are actually running another loop inside the first loop to find the minimum by this, like if like to find the minimum element actually. And then we swap by this, and then actually return the array. And here is an example of JavaScript implementations in the same way. Well, and what about the time and space complexity? The best case time complexity is big O n square. When it actually always same, and on average case the time complexity is also big O n square. and when it in random order and worst, it also always same. So the space complexity is big O n in place sorting, but it's not an stable sort at all. So when to use selection sort, actually, for learning purpose, you can use it, and when memory writes are costly, or if you have a small data set, like if you deal with a small data set, then you can use selection sort. But you need to avoid to use selection sort for large data set, and for perform critical apps, link list, and yeah. So for large data set, actually you need to use merge sort and quick sort for large data set. So I'll cover those up on my next video. Well, so let's have a quick summary. We need to find minimum and scan the unsorted part, and then actually we need to swap it to the correct place, and swap once per iteration. And big O n square the time complexity, big O n is the space complexity, and the minimum swap is big O n. Well, so I believe you now understand the selection short, and if you like this video, then please don't forget to subscribe my channel, and well, and see you on next video. Then till then, good luck.